This is a brand new algebra video, D4, which replaces the old one, and it's with great thanks to Ira, who's in the Monday group, for coming up with such a brilliant method. So this is the one I'm going to be teaching from now on. Now you use Ira's method when you are presented with an algebraic equation where you have got the letter on both sides of the equal sign. So for example on this one here, you've got y's on this side, but you've also got y's on that side of the equal sign. Now we're asked in the question to find out what is the value of y. There will only be one value of y where the left hand side of the equation is equal to the right hand side of the equation. Now there are two ways to do it. There's a very long-winded complicated way, which is the old version of video D4, but this one is the easy way, and you're able to use this because of the fact that it's multiple choice, so you know what 5 answers you're given and one of them must be right. So this is how we do it. We have to substitute each value of a that is an answer into the equation. So let's start with the first one. Okay, I'm going to write the equation out again, but this time where I see a y, I'm going to put the answer 12. So 4y actually means 4 times 12. Let's put that in brackets to keep it separate. Then I've got to take away the 5, which is up there. There's my equal sign up here. And then I've got my 7, which stays the same. And my plus y becomes plus 12 because y equals 12. So this number here I've actually got from there. So let's see if it's equal. Here's our equal sign. It's always a good idea to put that in first. 4 times 12 is 48, and then if we take away 5 we'll get 43. On the right hand side 7 and 12 is 19. So if the value of y is 12, both of these sides should be equal. Well, they're clearly not, because 43 does not equal 19. So that value of y must be wrong. So let's move on and try a different one. Okay, we've proved that a can't be 12, so let's try 3. That's our next value. So here we go again. Instead of 4y, I'm going to put 4 times 3 in brackets. I'm going to take away the 5 that's up here. There's my equal sign. I'm going to put the 7 that is there, and then instead of adding y, I'm going to add my value of y, which is 3. Let's see if both sides are the same. Well, the right hand side is easy. 7 and 3 is 10. The left hand side, 4 times 3 is 12, but we have to take 5 away, and that gives us 7. So if that value of b is correct, both of the sides are equal. They are not equal, so b cannot be the value that we want for our y. Moving on to the third one. Right, we've got rid of 12 and we've got rid of 3. Let's try 4. So on the left we've got 4 times the value of y, which is 4 in brackets. Let's take away 5 because it says take 5 there. And then underneath we've got our 7, add whatever the value of y is, which in this case is 4. Here's our equal sign. The right hand side's easy. We've got 11. On the left hand side we've got 16 take away 5, which equals 11. So because both of our sides are equal, this must be the correct answer for the value of y. We don't need to look at D and we don't need to look at E because we've proved that it is C. Now sometimes you're really lucky and you find that it's the first value, A, that is the correct one. Sometimes you're really unlucky and you find out that it's E, and if you do them in order you're just unlucky that you've had to try the other four first. Up to you which order you do them in. Just remember, whichever one makes both sides equal is the correct answer.